music to watch it like a Tamil movie. All right. Yes, what's up? Yeah. All right. I just need to wait for this to load. That's done, so I can move on. So, all right. So, transformation, please. Where did you get reflection? Why do you say reflect? Sorry. Like, where is the reflection? Kevin, can you hear me, man?
Yeah.
Kevin?
Yeah, I can
Hi.
hear you. I can hear you.
Kevin?
Hello?
Kevin?
Yeah.
Okay, I'm not hearing this guy. Kevin? This is Mike. I can't hear you, but can you speak?
Hi.
Say hi. Are you
Hi.
speaking?
Yeah, I'm
Hi.
speaking.
He's speaking. How come I'm not hearing him? Let's see what's going on. My audio. The audio is connected there. Kind of weird. My audio has.
Hello?
You can hear me, but how come you speaking? I can't hear on my audio. Pulse Quest live streaming is correct. Okay, that's okay. I'm not going to troubleshoot as long as I can see that. All right. Now, you say there's a reflection, so there's no negative sign anywhere. So there shouldn't be no reflection. So what is the transformation? Let's go back to Adare. How would you describe the transformation? Don't say horizontally go by -5, but you got an idea. How would you describe the transformation? Well, we don't say -5. Horizontal translate to the left by 5 units, isn't it? Now, let's go back to the original format of this. So, question here, Aaron, can I describe transformation if I have in this form? No. No, I can, isn't it? We cannot describe transformation on that form. But when we got this one into that form, we can describe the transformation, isn't it? Make sense? Now, let's going back to little adds on here. You all know how to describe the transformation, isn't it? So I want you guys to write the domain of this function. I mean, range of this function. Can you guys write the range of this function, please? The data practice, you should know how to write it. Range of that function. Kevin, you need to communicate on the chat. I'm not sure how come I can't hear you. That's kind of weird. Everything is on. Range of that function. How was your radical test?
I think that's okay.
That's right. Range, not the domain. I only need the range. Yeah. I say range. While you're writing x belongs to real ranges, nothing to do with the x. We did talk about this here last class. Where's your range? Correct. Correct. So you need to put the curly brackets in the beginning and the end. Okay, Kavya, what's going on? Yeah, you didn't review. That's okay. Okay, we did talk about how to find the range. The range for the quadratic function is going to be y belong to real, but also depends on this number. If you get a positive in front of it, we say y is greater than or equal to 3, isn't it? Now let's go back to what does that greater than or equal to 3 mean? Can I say therefore 3 is their maximum value the graph can take? No. How come? What do you think, Audrey? Can I say 3 is the maximum value graph can take? Audrey? Why not? What do you think? Anna, yeah.
It's the minimum value
Minimum value. What's makes you think minimum value?
because that means any number greater than 3 is valid.
Correct. This is the minimum value because we're saying that all the y values are greater than or equal to 3. So this is going to be a minimum value, isn't it? Make sense? All right. I'm not sure how does your math teachers really deliver math. Sometimes teachers will be just keep on going on the handout, fill it out, but you don't really see where did you use it. So the question here is, why it is important for us to find a maximum or minimum value of a quadratic function?
So you can find like the greatest.
Why? What is that useful?
Depends on the question.
But just in generally speaking, how does this help? I can tell a great example. Do you guys have a Tamil Students Association at school? Do you have a TSA? There are more Chinese people, so no TSA. Do you have a TSA, sir? What do you guys do? What does the TSAs do? Okay. What else? Do you sell items? Do you guys sell items? TSA sell items? Okay, so we have well, my school is the 90% is Tamil school, and then every month the TSA have a treat day. They sell items. So for the past few months, what they're doing is they're selling mutton roll or just butter chicken roll. They bring in 50, and then 50 will go like this. Just flick it, just the moment bell rings, you don't see that, it's gone. So last time for the treat day, what they did, they sold butter chicken rolls. And then also nectar. So surprisingly that the butter chicken rolls gone right away. The nectar sitting there, but people are buying. So I was supervising. I asked the kids, hey, how much you guys pay for the nectar? So 3 bottles for $15. So I was watching it. I was watching it until they got the $15. So we sell a cup for what? $1. So if I sell 15 cups, I got the $15. So I told them, now we're going to reduce the price to 50 cents per cup. And we still get the sales. So I make a profit. Then we still have some left. I say in the last 10 minutes, shout out is 25 cents per cup. Yeah, that gets disappointed. Why do I need to pay $1 in the beginning, now 25 cents? But we made a profit. So what's happening here, when you're reducing the price, you see the sales amount shooting up, isn't it? And then this is something that businesses do all the time. What time of the month Apple releases their new gadgets?
During the Christmas time.
They release during the Christmas, okay.
At the beginning of the month.
Every beginning of the month, Apple releases a new gadget.
It's in September.
Yes, they do release in September. September 7th or September that midweek after the school start. Why do they do it in September? But the students are already in the school. They should have shop for the people go to university need the student discount. They don't give a discount for the new product. When they release it, I wish all the new product come with a discount. It's always a high price. But why do they do it in September?
So that they can lower all the prices of the old products that they already bought.
But you need to make a profit out of the new products. Yes. Exactly. Christmas comes right after. September, October, November, December, Christmas. If they release in September, you're going to start the shopping around for your gift, isn't it? And then what do they do in Christmas time? They reduce the price. All the companies will be sending out you some rewards, or they're sending some bonuses. Okay, you can get an iPhone 16 for only $5 per month. So people will line up to get it. They know the price. They just got the profit. Now, most of the business model will fall into a quadratic function, right? So any quadratic function going to be either in the shape of this or either shape of this. We know this is going to be the vertex y value. We call it a maximum point. This is called the minimum point. For the businesses, it's important. They need to know when they can optimize the profit. But it's not just necessary for the businesses. So let's say that you're a basketball coach and you want to train people. And then you should be able to just let the people to throw the ball on a different angle to see if it can hit the basket, right? By adjusting where you're throwing the ball might go in a different direction. So there are a lot of sports simulations made up of using quadratic functions. Now, what we are heading back is you can only see the maximum value if it is in this form. What is the name of the form, Kavya? There's a name for this. What is the name? It's a specific name for this form. Yes, right. Vertex form. Because I can tell the vertex is -5, 3. Follow that? Okay. So what we want to talk about in the first lesson, if you have a function in the form of ax squared plus bx plus c, we want to know how to express that into vertex form. This process, going from standard form to the vertex form, is known as, you have finished learning this. How do we call the process? Going from standard to vertex.
We complete the square.
Yes, the process called completing square. So let's going back to some observation here. In this example, let me observe a few things on the factoring we have done. Look at the 10. That's half of 10. What is half of 10? 5. What is 5 squared? 25. Did I have that one sitting here? So the half of the x coefficient squared sitting there makes it a perfect square. Let's do the next observation. What is the b value? What is divided by 2? What is -6 squared is? Do we have that sitting there? So if a quadratic function in the form of x squared plus bx plus c, and if b divided by 2 whole thing squared is c, then I can rewrite this x plus b over 2 whole thing squared. It's a basically completing square. Oh, my water came out. That's okay. But let's go back to this example here. X squared plus 6x plus 8. How do you think it's a perfect square? Trinomial? What is in front of x? What's the value in front of x? In front of x. I know it's March break, but it's too early. Okay. First day of March break. Why you're confusing yourself? Kavya, what is the value in front of x? 6. What is half of 6? What is 3 squared? 3 squared is 6. Okay. Do I have a 9 sitting here? No. But we're going to do that happen. So what we're going to do, regardless of what's sitting here, we're going to bring that number. So what number I added? Half of b squared, isn't it? We have the 8 sitting here. But in math, when we add a number, to cancel the number, we can subtract. 9 minus 9 is 0. Now we can see something cool. The whole 3 terms is representing a perfect square because half of 6 is 3. 3 squared is 9. So can I rewrite it x plus 3 whole thing squared? What is minus 9 plus 8? -1. So y is equal to x plus 3 whole thing squared minus 1. Now, I'm going to going back to, hey, Kevin, I'm going to stop the screen share and then I'm going to restart the meeting because I want to hear you, sir.